First of all, you'll see my disclaimer, and it shows that I'm innocent and ignorant. That's good. But the real disclaimer is that I hate algorithms. I hate models. I learned the word emotional energy, and when Kevin showed his algorithms, I got so emotionally energized that my jet lag was cured. I actually tried to convince the organizers not to get me on stage here, and here I am. So there we go. Good morning, everybody. Let me talk about my hobby, personalized nutrition. And the real hobby is, how do we get people healthy? And before we get into this, I need to discuss a little bit, what is health? What is health? We know what a doctor would state about health, and he says everything needs to be okay, all values need to be good, homeostasis. But actually, I think health is something different. I think that if you look at what really happens, it's not about homeostasis, it's about the possibility and the capacity to maintain and regain homeostasis. If you look at inflammation, inflammation is bad. No, inflammation is good. Bad, good. What is it? Hello guys, what is it? Inflammation is a good thing if it pops up at the right moment and diminishes in the right speed. Yeah, the peak is important, the duration is important. If it gets too high, you're in trouble. You get damage. If it gets too low, you're not protected enough. Yeah? If it takes too long, you get disease, chronic stuff. And this is valid not just for inflammation, but also for metabolism, for oxidation, for mental stress. Even banks do stress tests these days. Yeah? So it's a universal principle. And this is what I think we need to focus a little bit on when we start to talk, maybe rethink a bit about nutrition. And I'm simple, as I said. I'm a biologist. I did the only study at my university where there's no mathematics involved, not even statistics. So here I am. This is me talking biology. I see three major overarching processes in health: metabolism, oxidation, inflammation. We might discuss mental, but that's it. If you look at where our nutrients, our essential nutrients, act, it's there. It's exactly there. This is where our micronutrients, our essential nutrients act. Give me one that doesn't. Yeah? The point, of course, is that we don't look at these inner processes. We look at other areas, and let's call them health targets. And you recognize them. They are subject of a lot of nutrition research. You can find biomarkers to quantify those, but realize that the real driver for optimal processes are these inner circle processes, the overarching processes. And then, of course, the doctors look to the outer circle, the diseases. Realize that there's a continuum between these inner processes, mitochondrial optimization, to these health areas, to these diseases. Yeah? Now, if you combine this with what I've shown you in terms of stress, flexibility, robustness, resilience, we come to this point. Now I go to the doctor. The doctor asks me, are you healthy? And he does the test. Yeah? Glucose, cholesterol, body weight, and hypertension. The Framingham Heart Risk Score. And he calculates me, and this is my chance of dying from one of these blue things. And it's good with me, and that's okay. But this is statistics, and I don't like this. I'm a physiologist. I have rearranged these areas into a scheme, a systems scheme. Yeah? I'm now calling myself a systems biology because it gets me more money. But this is what it's all about. It's a system that interacts. Yeah? Now, what happens if I eat glucose? We'll do an oral glucose tolerance on the system. Glucose goes up and it goes down. Like I've shown you, and if you're obese, that is insulin resistant, it goes up higher, it takes longer. Is that what happens? No, there's a lot more that happens. Insulin goes up and down. Oxidative stress goes up and down. Blood pressure changes. LDL cholesterol, total cholesterol, triglycerides, even adiponectin. Many, many parameters on hitting the system with just a single molecule, glucose, start vibrating. Yeah? This is funny. It's like, I am like a shock absorber. This is health. Health is not static glucose. Health is every process in my body interacting to regain and maintain homeostasis, whatever it is. So we've brought this into perfection. We've done a whole lot of omics-based challenge tests with glucose, with lipids, proteins, with any kinds of mixtures. We've measured hundreds, that is thousands, of proteins and metabolites, and we've come up with this scheme. We can now quantify, using a single, simple challenge test, something like an oral glucose tolerance test, all the relevant processes and organ-based processes involved in metabolic health, whether it's the liver, or the muscle, or the pancreas. And this is not rocket science, it's published, and we've brought this together. So what we can now do, what I'm saying is, I have a new biomarker. I have a biomarker of flexibility, systems flexibility. And if you do this, you can quantify your health in terms of this new definition in such a manner. Yeah? Now, this is a simple scheme. This is a simple way of representing how I can quantify all of this. And now I can see where dietary components act. And funny enough, they act there. It's like, and unlike pharma blocks these processes, nutrition optimizes these processes. Quercetin, selenium, and zinc work in ectopic lipid overload, fatty liver. You can go with carnitine and choline, and so on and so on. And you can enter your own hobby nutrient somewhere in the scheme, and you'll note that they function in optimizing flexibility processes. Now, having done this, we have a model. We have a model. I have a model. We have modeled this into 3 axes. Inflammatory, lipids, and carbs. Flexibility, so not lipid parameters, lipid flexibility parameters. So let me go back. All of these biomarkers here were grouped into categories, and some are related to lipids, some to carbs, some to inflammation, and we've made a mathematical approach on how to use these biomarkers, here they are, the processes, into a single scale based on their flexibility. Now, these are people that are healthy, but if you're not healthy, you're here. What do you need? What type of compounds would you need to is there a mouse moving there? I think so, right? To optimize these processes. Now we can go personalized based on my flexibility, my system's flexibility scheme. And actually, we've done this. We've done this for, in this case, 100 people, subjects, 50 males, 50 females, and here you see the scheme. They're all healthy. They were all healthy according to the doctor. Glucose was okay, blood pressure was okay, body mass was okay, but they had a range. The range was lean and young, middle-aged, relatively low adiposity, middle-aged, normal adiposity, middle-aged, high adiposity, and elderly, almost me, normal to high. 100 persons grouped in there. And what you see is those groups are represented by their 4 biomarkers in this flexibility health space. They're all healthy, but they are there. Hey, this is another model, 2 slides on models. I'm surprising myself. Now, if this is a health space, and we know where optimal health is, can we then think about how to move people in these spaces? What diet best optimizes the system's flexibility of this lady? Interesting. We know their data, her data. We have categorized, quantified all the relevant processes, and we know what nutrients, micronutrients, essential nutrients, macronutrients, would fit in these processes that would optimize all of this. Is this the way to start thinking about dietary advice? If so, this is utterly personalized. You need some bucks in order to quantify somebody, but it can be done, and we've done it. Yeah? Simple example, the Cooperative study in Cordoba, Spain, 1,000 subjects, 600 of them, no, all of them were categorized over a period of 5 years on an oral glucose tolerance test and a mixed meal challenge test, and they could be categorized in various degrees of flexibility, and this is again normal, impaired glucose tolerance, impaired fasting glucose, and so on. And in this way, we could categorize whether their insulin sensitivity, their glucose intolerance was based in their muscles, liver, pancreas, or systemic. Then 2 diets were given to these subjects, 2 times 500, yeah, low fat and Mediterranean. And this is interesting. What you see is that subjects that were specifically muscle insulin resistant specifically profited from a Mediterranean diet. And people that were specifically liver insulin resistant specifically profited from a low-fat diet. And once they were full-scale insulin resistance, the Mediterranean diet was better than the low-fat diet. This is a simple proof of the pudding, 2 times 500 subjects, 5-year times. This was measured after 3 years, where an approach like that would fit. Yeah? So here we are. The overarching processes linked to consumer goals. Here they are, personalized nutrition-based consumer goals. Connected to organs. I've shown you how we can quantify these processes. Yeah? These are then underpinned by what I'd call flexibility processes and sub-processes. Yeah? These are the engines that make things happen. And we can quantify those according to these systems flexibility biomarkers. And all the way down there, there's the nutrition part. The schemes of nutrition, how they interact on a molecular basis on this scheme. And I've shown you how we have figured this out in our metabolic flexibility part. But this is a way to think about how nutrients might connect to specific goals. Yeah? Mechanism-based. In that way, we now, so this is the introduction. How far am I in time? I think it's, that's good. I can make that. So far for the introduction. Now, if we have a lot of literature and a lot of studies published already, there's a lot out there. Can we use them to bring this into practice? A study, in the end, produces a decision. If you have hypertension, use low salt. Yeah? If you have a body mass that's too high, eat less calories. And we start building advice based on decision trees. Yeah? Here you see an example where you simply have a number of decisions, one after the other, brought into practice as schematic in the area of exercise. Now, if you bring this a bit more personalized or a bit more into practice, a decision tree here on fatty acid desaturases, a genetic polymorphism related to food intake, genetics, and measurements in plasma. And here, taking 3 sequential decisions, you come up with 12 different types of recommendations for related to the intake of polyunsaturated fatty acids. This approach is relatively simple and can be made based on what we know and what's in the literature. Yeah? Using the scheme that I presented to you, we can build on this and start introducing the flexibility schemes. Yeah? So we have the measurements that we do, whether it's from metabolomics or the simple bathroom scale, and bring this into personalized measurements and then come up with decisions. Yeah? Now, and I'll skip a few slides until here, because this is important. If we here discuss science and mathematics of models, of personalization, you need to have some knowledge about yourself. And as long as this is in the area of research, then it's easy, because some researcher pays for your data and he takes care of it. But in the end, in real world, I'll need to know who I am in terms of health data. Yeah? So the question is, who owns my health data? Yeah? This is a fundamental question, because if I have no access to my data, I cannot get personalized advice. Yeah? So companies like this one start to thrown into this area, and this was a very nice one. They actually said, okay, we'll help you gather your own data. Now, Apple knew this, and they bought them. Yeah, clever. So there we are. And then Apple hired a guy, a genius in this area, Stephen Friend, who started to connect all of this. And there we are, guys. Is Apple going to run away with my health data? I don't think so. In Europe, we are building something that we call a health data cooperation. It's a legal structure where all of us together own our own health data. In Europe, this is legally the case. I'm not sure how in this presidential period is the case in the US, but think about owning your own data. Think about being able to valorize your own data. If I have access to my own data, I could come to Kevin and say, Kevin, how can I plug in my data in your model so that I can get advice? I have no clue how to do this. So he'll be tempted to make a user interface that would work for me. And then to all of us who build models, yeah, so we start to build a new ecosystem, building based on my personal data. And I think that is where the future needs to go to. Research is nice, it builds the foundations. Bringing this into practice will need to be built on my data. Now, 2 last slides. We are talking about weight loss, obesity, fine. I'm working, I have 10 more years to go in my career, and I've chosen to cure type 2 diabetes. The funny thing is that type 2 diabetes is just as curable as obesity and just as difficult. From a systems flexibility point of view, and this is the slide that shows it, and there are many of those studies, type 2 diabetes is a metabolic disease where all processes are reversible. Regaining systems flexibility can be done. Yeah, this is a study done in Newcastle in the UK, where in a period of 8 weeks, full regaining of system flexibility because of loss of adiposity in the pancreas was regained. Now, if you look at the scheme I've shown you, the health space, on the right side you see my 100, that is 50 in this case, 70 healthy persons here. The yellow dots are 20 more type 2 diabetics. They're the same, they're just a bit more out of scale. Can we use the same technologies, tricks on dietary advice that I've shown you to cure type 2 diabetes? Well, that's my cliffhanger. See you next year.
Thank you, Ben. We have time for some questions. Richard Black.
Thank you very much. Richard Black, Quadrant T Consulting. That was really interesting. I have a question about biological systems and buffering. It seems to me that most systems are buffered to some extent, so that small inputs, they shift a little bit, but they come back, right? It's only strong inputs consistently over time or massive inputs over a short period of time that really shift the system. Is that a fair... And so where I'm going with that is to say diabetes and obesity develop with a subtle push over a long period of time.
Yeah.
And you're arguing that we should be able to rearrange that and shift it back. Isn't it not going to take either a massive push over some short period of time or, again, a very subtle push over a long period of time? And then I worry about the behavioral consequences of that.
Hold on, one thing at a time.
How can we maintain that?
One thing at a time. The flexibility concept, you say subtle variation is within a bandwidth. True.
Yeah.
The point is, the healthier you are, the broader the bandwidth, and that's the point. Yeah, so I need to oil my flexibility machinery to the extent that I'm as flexible as I need to be, even for big meals or strong bouts of exercise. That's the point. Yeah.
So then, but in shifting then the diabetes, your last comment, how do you create that pressure over the longer term, which I would argue you could do if you had the knowledge, from a behavioral perspective?
Yeah.
How do you get people to actually maintain that pressure on their own systems in order to shift it back
so
to
first, an intermediate answer. Diabetes is nothing else than a prolonged adaptation to the effort of regaining flexibility, which means that if the system is still intrinsically flexible, it can be cured. Now, the behavioral aspect is the big thing, of course, yeah, and there we come to David Corby and to all the other issues. This is a societal issue. I could give another talk or 2 or 3 or 4 on, so this is about the health system, but there's a social system and a healthcare system. And if the healthcare system doesn't change and the social system doesn't change, we are fighting like the Don Quixote in Spain.
Yeah, okay, thank you very much.
Yeah.
Hi, Mike Kelly. So a couple of years ago at this meeting, there was a special workshop after the meeting on the FenFlex project. And yeah, I'm not sure if people here are aware of it. So first, I'd like to encourage you maybe to go back to the collaborators and propose a session on FenFlex for this meeting to update us. So to that point, I was wondering, now that results are coming out, I think part of it was to inform public health recommendations. And I wondered if you could comment on any progress toward that goal of the FenFlex project.
The FenFlex, that's a good point. So the FenFlex project actually was a European Union funded project, Nutitech, and an industry funded project, FenFlex. Nutitech has finished, and I'm actually here to write the main paper, so I'll go and hide in my hotel to write the paper again. FenFlex had as a follow-up, FenFlex 2, which is another government-funded industry collaboration to go all the way towards establishing biomarkers of phenotypic flexibility. Yeah, and it's embedded in a bigger wave of systems thinking of flexibility. Yeah, thank you.
Martin Kohlmeier, UNC Nutrition Research Institute. Very stimulating ideas. My concern is, how do you test this? How do you make it science by really introducing rigorous testing? Because you're talking about concepts. We have to translate it into reproducible, actionable, prescriptive kind of algorithms.
Yeah, so I've essentially talked about 2 issues. One is the concept of systems flexibility, and this has been tested big scale and is still being tested. The other is how to apply this into personalization. And here, indeed, most is based on literature and studies like that. The studies that actually go personalized from this point of view, we've done 2 or 3 of those, but not a lot. And I agree, if we go all the way, we can only build on validated and substantiated decisions. Yeah.